The topic for this lesson is mesh analysis. A closed voltage loop is also known as a mesh. On application of Kirchhoff's laws, it can be shown that a loop can carry more than one current. Each of the mesh currents can flow in and around the entire loop. However, a particular resistor may carry one or more mesh currents. The standard procedure is to assign clockwise currents in each mesh and proceed with the KVL equations. In the example shown for mesh ABEF, using the KVL equation yields E1 plus I times R1 plus I times R2 plus I times R3 minus I2 times R3 equals 0. Note that I2 flows in the opposite direction in resistor R3 compared to I1. This equation is reduced to read 10 plus I1 times the quantity R1 plus R2 plus R3 minus I2 times R3 equals 0, or 10 times I1 times the quantity 3k ohms plus 2k ohms plus 1k ohm minus I2 times 1k ohm equals 0, or 10 plus I1 times 6k ohm minus I2 times 1k ohm equals 0. We will label that as equation 1. In the mesh BCDE, the KVL equation yields I2 times R3 plus I2 times R4 minus E2 plus I2 times R5 minus I1 times R3 equals 0. Notice that E2 here has a negative sign, and since the opposing current is I1, the term I1R3 has a negative sign too. This equation is reduced to read I2 times the quantity R3 plus R4 plus R5 minus 15 minus I1 times R3, which is equal to 0. Or I2 times the quantity 1k plus 5k plus 6k minus 15 minus I1 times 1k, which is equal to 0. Reducing further, I2 times 12k minus I1 times 1k minus 15 equals 0. This is labeled equation 2. Thus the equations 1 and 2 reduce to 6I1 minus I2 equals minus 10, equation 3, and minus I1 plus 12I2 equals 15, or equation 4. Multiplying equations 3 by 1 and equation 4 by 6, we get 6I1 minus I2 equals minus 10, and minus 6I1 plus 72I2 equals 90. Adding these equations results in the following equation: 71I2 equals 80, or I2 equals 1.13 milliamps. Substituting the value of I2 in equation 3, we get 6I1 minus 1.13 equals minus 10, or I1 equals 8.87 divided by 6, or minus 1.48 milliamps. The negative value of I1 indicates that it is actually flowing counterclockwise or opposite to the direction shown.